Hello everyone. I'm Kentaro Maeda from LINE Financial Development Center. The title of my presentation is Developing Microservice Infrastructure for LINE Securities. I will talk about LINE Securities first. I will then talk about our system challenges at the time of service launch, how we considered and built microservice platform, its benefits, and our future prospects. Before explaining about LINE Securities, I have a question for you. Have you ever done stock investment before? I didn't have much investment experience either, since I thought that investment was difficult and would require knowledge and fund. I'm sure that many people think that way. LINE Securities is a service launched with the goal of making investment more accessible and easy. The service allows people to start with a small fund using a very simple procedure and UI. It was launched in August 2019, targeting young people who had never invested in the past. One example is a service called eKYC that has been provided since the start of the business. Let's say that you hear in the news that a share price for a company is 2,000 yen. However, you can't actually buy a share for 2,000 yen because in the stock market, stocks can be only traded in units of 100 or 1,000 shares. If the share unit is 100 shares, 200,000 yen is required to purchase the 2,000 yen share. Our eKYC service sits between the customer and the market and allows the customer to trade from one share at 2,000 yen. Therefore, people can trade in small amounts and they can trade until 9 p.m. in their spare time with small funds. Initially, the number of tradable issues was 100, but now it has expanded to 1,015. Another example is eKYC, Electronic Know Your Customer. It is necessary to strictly check the identity of the person who opens a securities account. Therefore, it was necessary to mail identity verification documents such as a copy of driver's license, and it took at least 4 business days to open an account. We were among the first to introduce eKYC, where the identity verification can be done with a picture of yourself and the documents sent from your smartphone without the need to send by post. It now takes only a day at shortest, and you can start trading from the next day after opening an account. We are expanding our services. In November 2019, we started investment trusts. In December, we launched the time-limited discount sales of shares on a first-come, first-served basis. From the beginning of this year, we have started LINE FX and spot trading and margin trading of domestic stocks. This year, in August, the number of accounts exceeded 300,000. We are continuing to create new services. This shows the scale of the system we built in our data center. We don't develop everything in-house, and we use various external services which are not included here. We configure the system with highly independent services as microservices. The number of services was 11 at the time of starting business, but it's now 7 times larger at 70. On the other hand, the increase in the number of servers was only 3 times. I will talk about what measures we have taken to scale the number of services efficiently. Let me talk about the issues we faced at the start of our business. The biggest issue was that LINE Securities system was an on-premise system with static configuration. LINE has a private cloud called Verda, But Verda at the time did not meet the security standards of the financial industry. Therefore, we started our operation on a separate network from other LINE services. There were network configurations and dedicated LINE connections for higher security, which hampered server setup procedure. This shows the complicated server setup procedure. LINE Securities system was developed based on microservices, but no consideration had been given to standardization of each service and communication between services. It was a static configuration in which a cluster was formed for each service, with a domain and a load balancer for each service. And services communicated with each other using certificates. The procedure for building each service was different due to the network and complexity and dedicated lines. As a result, the build took about 2 weeks even for a skilled engineer, and the cost of adding services was extremely high. Next issue was the ineffective use of resources. The figure below shows the server load of LINE Securities on one day. The securities system has a clear characteristic that 90% of access comes when the market is open between 9 a.m. and 3 p.m. Servers were set up by forming a cluster for each service, which required us to set up the server to match the peak load of each service. We ended up having many servers that do not use resources or at all except during peak hours. This meant that we had to set up redundant servers at high cost every time we added a service. In order to improve the speed of service development, we introduced common development rules and unified server setup procedures. We decided to build a dynamic service platform on-premise that enables effective use of resources and flexible scaling. Now, I will talk about the main topic of this session, developing microservice platform. We first set a policy for building the service platform. The important thing was to assemble small components that each do one thing well. This was because the development members at the time were developing services in parallel, and the number of people for post-release operations was limited. We had to do development with a minimum headcount. We thought that if we used a large package that we didn't understand, it would be difficult to do failure cause analysis or to do updates after the release. Therefore, we decided to link small tools that were easy to understand. In fact, this platform consists of installing about 4 resident processes on the server. We also decided to utilize OSS in order to reduce dependency on infrastructure or specific products. There are many convenient in-house tools available in LINE's internal network. But there was a possibility that we may have to run our system outside of LINE's data center for data recovery or business continuity. Therefore, we decided to reduce direct dependency on proprietary tools by using OSS or through abstraction when using in-house tools. After experimenting with different tools, these are the 7 tools that we chose. As a result, we chose more tools that were cloud native. The features of these tools are also useful for running dynamic services on-premise. I will talk about how we combine and use these tools. The figure on the right outlines a microservice platform. The aim of this platform were dynamic deployment, management, and network masking. We stopped forming clusters for each service and instead set up a general-purpose server cluster called server pool. In this server pool, any service can be deployed and resources are shared. The management servers at the top centrally manage the deployment to the server pool, and the edge receives communication from the outside. The load balancer, domain, and certificates are centralized at the edge, and only the edge receives communication from the outside. All the complexity of the network and dedicated line is concentrated in the edge. The edge and each service in the server pool communicate directly without going through the load balancer. That's the overview, and let's now look at each component more in detail. Let's focus on the management server and server pool. The main tools on the management servers are Nomad, Vault, Consul, and Control Plane. These tools take information from the server pool for management. Nomad launches a Docker image in any server pool. Vault manages secrets and certificates. Consul manages service addresses. And Control Plane controls communication between services. I will explain more in detail. This is the server pool. In addition to agents such as Consul and Nomad in the server pool that take information from the management server, Docker is installed to run the services. By using Docker, the binary and runtime of the service can be distributed in one image. In other words, the server pool can run any service with Docker installed. The benefit is that you can standardize the server pool setup. Since the work of building a server pool with Docker is standardized using Ansible, all that is required to do to add a new server is to run Ansible. Another benefit of using Docker is there is a clear boundary between service developers and infrastructure, allowing us to have development rules. Common rules are set to facilitate development. If the rules are too tight, they hinder development, but we do need some kind of guidelines. By using Docker as the boundary, we are able to have configuration that is easy to control as infrastructure while allowing more freedom in development. For example, logs. Previously, where to put logs was coded directly in the service. In this configuration, the service developer only has to output the log to standard output. The infrastructure controls where to send the logs. In the example on the right, Docker logs are collected by TD agent on the host and sent to tools such as Elasticsearch and Slack. This configuration allows for easy changes and tuning of logs. Similarly, for metrics and distributed tracing, service developers only do minimal setting of libraries and format, and the rest is controlled by the infrastructure. You can develop any language using Docker, but we use Spring Boot and Kotlin as standard languages. I will now explain about Nomad. Nomad is an application deployment tool from HashiCorp. Nomad follows the configuration file called job file, finds a server with sufficient resources, and starts a Docker image. The job file contains the number of containers, Docker image, and CPU and memory limits. Each service of LINE Securities basically runs a Docker image in Java and Envoy as a pair. In the figure on the right, a job count 2 starts Envoy and Service A application image as a pair. And when the job is submitted to Nomad, Nomad selects 2 servers and starts 2 containers. Nomad monitors the containers after startup and constantly checks whether the job file conditions are being met. When a job with a changed number of containers is resubmitted, or when the container abandons, Nomad will automatically adjust the number of containers. It also does rolling updates. It is an important tool that is indispensable for deploying applications. Next, I will talk about Consul. Nomad launches Docker image on any server, which means that we don't know which servers or which ports the services will run until Nomad launches them. Consul is a mechanism for managing such services. Consul, also from HashiCorp, is a tool for cataloging dynamically changing services. It might be helpful to imagine it as a DNS or directory service for microservices. Nomad registers the address of a service it starts in Consul. In the figure on the right, it shows Nomad registering the address of the service it started in Consul. 2 addresses are registered. You can get a list of service addresses by sending an API query with a service name to Consul. Consul is also a great tool to monitor service states by setting a health check with the API notification on service state changes. Envoy and control plane provide the mechanism that make microservices look like a monolithic service mesh. Envoy is a feature-rich HTTP proxy server that is launched by Nomad as a sidecar with a service. It proxies both outbound and inbound communications for the service. When a service communicates with another service, it goes through Envoy, which connects to the destination. So the service only needs to communicate with Envoy without worrying about the destination. So how does Envoy know the address of the service that is dynamically started by Nomad? Envoy has an API called XDS that rewrites its own settings. Also, as mentioned earlier, a service address are centralized at Consul, and these 2 are connected by control plane. Control plane detects changes in the service status of Consul and notifies Envoy. Please look at the figure on the right. So far, we have been focusing on deploying service A, but suppose that service B was running on another server. Envoy for service B has a setting to communicate with service A. When service A is deployed and the information in Consul is updated, control plane detects the change and rewrites the address of service A in Envoy for service B. After that, when there is communication from service B to service A, it goes through Envoy, reaches service A. We built our own control plane in-house. With control plane, we can not only add new services, but also quickly scale out or respond to service state changes such as abnormal end. Lastly, I will talk about CI/CD. In order to properly manage the deployment of microservices, we have created a CI/CD pipeline and clarified the division of roles. The security system requires us to keep a record of when and in what version releases were made. We were doing version control of Docker images and configs using Git version control and deployment with AWX. I will talk more in detail. It is natural to do CI with Jenkins to create Docker image, but in order to deploy, it is necessary to associate secrets such as password and other contents with the deployment. Therefore, we set up a dedicated Git repository to store the settings for version control. We use Vault to manage secrets such as passwords. for secure secret management. In addition, in order to keep a history of deployment, we use AWX that executes Ansible processes with a GUI. The destination of images for deployment and the association of the operation with Vault and Nomad are all written in Ansible and executed together in AWX. This provides a unified deployment method. That was the explanation on the platform. And next, I will talk about the benefits gained. First, it's much easier to scale out. After the release of spot trading in May, access to LINE Securities increased by 2 or 3 times, resulting in a shortage of resources. So we decided to add more servers. It took less than a day to scale services after adding servers. This was because the server's setup was standardized with server pool, and the container could be deployed on any server using Nomad and control plane. It also promoted the effective use of resources. For example, multiple services can coexist in one server, or nightly batch processing can be performed on an idle server in the server pool. And the development speed has been improved. The boundary with containers allows developers to focus on implementing services, not worry about infrastructure. The same is true for the infrastructure side, and it is easier to do enhancement and tuning with limited impact. Lastly, I will talk about remaining issues and prospect for the future. With the platform, we have successfully standardized and streamlined the application execution platform, but there are still things we want to improve, mainly storage and operation monitoring. First are the logs. With the increase in the number of service users, there are 200 gigabytes of logs generated per day. We need to consider a long-term policy on the storage and analysis of the logs. For operation monitoring, historically, multiple tools such as Prometheus, Zabbix, and other in-house tools, and as well as Slack, are being used together. Since we had to do everything on-premise, middleware such as Kafka, Elasticsearch, and Airflow are managed in-house. There is significant operational workload. There are 2 plans to solve these issues. One is giving another try at using LINE's private cloud Verda. If we use Verda, we can scale better, and we can use middleware such as Elasticsearch and object storage in the cloud. And Kubernetes will also be an option for us. By using these, we can expect to reduce operational workload. We are currently working with the Verda team to meet the security standards. The second is the consolidation of operational tools and log functions. We are considering a wide range of options, including open source, commercial, and in-house tools, as well as cloud and SaaS products. This is the summary. We have developed a flexible and scalable application platform. It is the mission of our SRE team to continue to promote automation and efficiency. Using this platform, we will scale both LINE Securities and its systems, aiming for 1 million accounts. Thank you very much.